Hi gents, welcome back. We're going to do some revision here for this week, and what we're going to start off with is a fantastic year of maths. This is 2002 and it's got a couple of good questions here that will get us just practicing a few different things. So we're going to do two questions. We're going to do question 2a there, that's a simultaneous equation. And we're also going to do a cubic equation here, okay? So there's two parts to it. So actually we'll start off with question 2a first. I would definitely be expecting a simultaneous equation on my exam. 4z equals 7. Okay. That's my first equation. I've got x plus 3y plus 2z is equal to 1, equation 2, and minus y plus 3z is equal to 8, equation 3. I notice very nicely in equation 3 already they've eliminated an x. So you also want to eliminate an x, and you want to do it from 1 and 2. So what I suggest we do is this: we'll leave equation 2 alone, x plus 3y, and in fact equation 2 alone, x plus 3y plus 2z is equal to 1. That's equation 2. And equation 1, to get rid of the x's, multiply everything by minus 1. Minus x minus 2y minus 4z is equal to minus 7. What do we have? No x's, that's exactly what we wanted. We now have 1y, we have minus 2z, and we have minus 6. I might call that my fourth equation. And look at that, I had it so nicely lined up that we could actually place equation 3 right here, and it would mean that the y's would already go. Okay, they're already teed up to go. So y's go, so we're left with just z is equal to 2. Okay, and now what you can do is you can put that back in. For instance, you can say that y minus 2z is equal to minus 6. Well, if z really is 2, and it is, we get z minus 2 by 2 minus 4 equals minus 6. So we add minus 4 to both sides, we get y equals minus 2. And then we go up to, let's say, equation 1, and we say x plus 2y plus 4z is equal to 7. And we get x, well, y is minus 2, so that becomes minus 4. Z is 2, so that becomes plus 8 is equal to 7. So we get x plus 4 is equal to 7, and x is equal to 3. And just for our examiner's sake, we write all our answers here. There you go. So there's a little simultaneous equation for you just to practice on and just to see if you're good for it. Oftentimes there will be an extra one here, and you'll just have to get rid of the x's from two equations and then the x's from another. Okay, here's our cubic. It's x cubed. I'm going to write it down here. X cubed, excuse me, flicking back up and forth, minus 4x squared. X squared, I think it was plus 9x, maybe plus 10. I don't know, maybe minus 10. Yeah, minus 10 equals 0. It says that, I mean, the words are important here, it has one integer, one whole number solution, root, and two complex solutions. So remember what you're meant to do to solve this. What you're meant to do is you're meant to try and pick a value. So try for x equals 1, for instance. Let's throw 1 in there. What do we get? 1 cubed is 1. No good. Oh, well, sorry, we don't know that yet. Minus 4 times 1 squared. 1 squared is 1, so minus 4 plus 9 minus 10. Does that give me 0? It does not give me 0. I can be fairly confident of that. Okay, what about try for x equals 2? Okay, 2 when cubed. Please don't look that up. It's 8. Minus 4 by 2 squared, so that's minus 4 by 4 minus 16, plus 18 minus 10. Okay, what do we end up getting here? Well, if we add together 8 and 18, we get 26, and we add minus 16 minus 10, we get minus 26. There it is. Okay, so we have one of our solutions. X equals 2 is a solution. Okay, what does that mean is a factor of? Can you remember? Is a factor of? And it means we could say that if x equals 2, that implies that x minus 2 is a factor. What does it mean to be a factor? It means it divides into it. So x minus 2 should divide into x cubed minus 4x squared plus 9x minus 10. Feel free to use synthetic division here, the box method as it's known as. I won't just for this. Okay, x divides into x cubed to leave x squared, and you multiply back out. So x squared by x is x cubed, x squared by minus 2 is minus 2x squared. It's been a long time. You definitely want to practice this stuff again. Draw a line, change the signs. X cubed minus x cubed is nothing. Minus 4x squared plus 2x squared is minus 2x squared, and bring down the plus 9x and start all over again. X divides in to leave minus 2x. You multiply back out, you get minus 2x squared, and you get plus 4x. Draw a line, change the signs. So we get no x squareds, as should happen. We get plus 5x here, and don't forget minus 10, and this should divide in now nicely. X divides in to leave plus 5, and when we multiply plus 5 out, we get plus 5x, and we get minus 10. Lovely. When we draw a line and change the signs, we get not an answer of 0, but a remainder of 0. So it means that x squared minus 2x plus 5, that's one factor, and the other factor is x minus 2. Both of those multiply together to give us 0. Well, we know what this one would mean. It means that x minus 2 is 0, in which case x is 2. That was the thing that we already got. Okay, that was up there. But now we have to do x squared minus 2x plus 5 equals 0. So normally you would just send that in and, you know, get out 2 answers, and you had to have all 3 answers. But what it said was that one of the answers was an integer, a whole number. True, we got that. But the other 2 are complex numbers. So it means that when we do use our formula, okay, we definitely wouldn't try to factorize this, okay, not with complex numbers. We know that a is 1, b is minus 2, and c is 5. And when you use the quadratic formula in the tables books, b squared minus 4ac all over 2a, what are we expecting? If you're going to get a complex number, try to predict what is going to happen here before it happens. That's 4 times 1 times 5. What's going to make this complex number as opposed to just a regular number? And hopefully you're going to tell me that something specific is going to happen under the square root sign. And that is that we are going to end up with a negative number. So we get x is equal to 2 plus or minus the square root of minus 16. There it is. And remember, root minus 16, the square root of minus 1 is I. And you can break this up into root 16 and root minus 1, or put another way, 4i. So x is equal to 2 plus or minus 4i, and all of that is being divided by 2. So when you half the thing on top, you have x is equal to 1 plus or minus 2i, and don't forget there was also the original solution of x equals 2. So all 3 answers written out nicely. There you go. A nice little question to do some revision on. That's the sort of thing I suspect that you'll want to, having viewed it, go back over it, retry it, go back up to the start, have a look at what the questions were, and go from there. But those are two questions where you're doing simultaneous equations, and another one where you are solving a cubic. While I am at it, I will try and get me another simultaneous equation. The book is eluding me, so I tell you what, I'm just going to pause you for a quick second and grab it. And we're back. Okay, this is one that I've just nabbed from 2016. here, and it's another simultaneous equation. So 2016 paper 1, question 2, just in case you're keeping track. Now this is the most horrible of all the simultaneous equations that they've asked in the last while. We've got equation 1 and we've got equation 2. I think we'll notch this down a little bit so that we can fit our writings in. That's easier, yeah, okay. Equation 1, equation 2. So just remind yourself how exactly you go about these. What you want to do is you want to go to the easy one, that's number 2, the linear one you want to go to. You don't want to touch the non-linear one just yet. And you want to get either x equals or y equals. Okay. So in this case we'll get x equals 2x is equal to minus 3y minus 1, and x is equal to minus 3y minus 1 all over 2. Just goes down. Okay, don't call it minus, you can, but don't call it minus 1.5y minus 0.5. Okay, just don't. I would leave it like this and have courage in your mathematical ability, as foolish as that may be. Okay, what we want to do is we want to take what x is and sub it into 1. We will be able to do this, okay, if you just take your time and do it slowly. So instead of saying x squared, x is minus 3 minus 1 over 2. So instead of saying x squared, it's minus 3y minus 1 over 2 squared. Plus, instead of x, we say minus 3 minus 1 over 2, sorry, minus 3y minus 1 over 2 times y plus 2y squared is equal to 4. Here we have an equation, albeit ugly, that has only y's and numbers in it. Therefore, we can solve it. Okay, squared means multiplied by itself. Just like take it nice and slowly with this. Okay, we need to multiply these together. Well, y is y over 1. So top by top, bottom by bottom, we get minus 3y squared minus y over 2. We get plus 2y squared, and here we have 4. Okay, top by top again. So nice and slow here. 9y squared plus 3y plus 3y plus 1 all over 4. Added to. Now this bracket is kind of annoying, but we'll leave it there just for a second, I think. Because really the bit that's actually most annoying is the fact that we're dealing with fractions. Here's what I suggest that you do. Multiply everything by a specific number. Have a think about what the number is going to be. If you said 4, well done. So the first bit by 4, well, you know, it's going to be 4, you know, 4 by this divided by 4, it'll just leave you with that on its own, 9y squared plus 6y, I suppose we can call it plus 1. Now this thing here, I'm going to do this one slowly. In fact, maybe I should do the other one slowly. I'll say we're doing 4 times this plus 4 times this thing here plus 4 times that thing there is equal to 4 times that thing. Why have I picked 4? Because all of the fractions divide in. 4 divides into 4 to leave 1. So you've one amount of 9y squared plus 6y plus 1. 2 divides into 4 twice. So you've 2 amounts of minus 3y squared minus y. This is simply 8y squared, and this is simply 16. So what do we have? We have 9y squared plus 6y plus 1. Don't add 1 and 2, that would be a terrible PEMDAS mistake. 2 is multiplying this thing here. So it's minus 6y squared minus 2y plus 8y squared is equal to 16. Okay, let's add the y squareds. Those are, well, it's going to be 11y squared as far as I can tell. Let's add the y's. We have 4 y's. And we have minus 15 equals 0. Okay, you might be tempted to pull out the old formula, but it can only be 11y and y. And it's 1 and 15 or 3 and 5. Surely we can work this out. 1's plus, 1's minus. Yeah, We place a 15 here and a 1 there, and a plus here and a minus there. Just a quick check, plus 15y, minus 11y. So that's good. So we have 11y plus 15 equals 0, or y minus 1 equals 0. So 11y is equal to minus 15, in which case y is minus 15 over 11, or on this side y is equal to 1. Remember, it was a simultaneous equation. We were meant to get what x is as well. So, and remember this, it's specifically what is x when y is a particular value. So when y is 1, well, let's go back to our equation. Go to the easy one, okay? Here's a nice, well, relatively easy one. I mean, you can use this one as well, but it's all the same. Just don't use the x squared one, that's all I'm saying. X equals minus 3y minus 1 over 2. Let's zoom back in. Okay, let's place y equals 1 in there first of all. We will get minus 4 on top over 2. So that's minus, that's minus 2. So there's one answer. X equals minus 2 and y is 1. And the other answer, oh, well, shall we just get a calculator? I think we'll just get a calculator. You know what? Let's not get a calculator. No, I'm putting that back. Let's not. Okay, x is equal to minus 3 times y, which is minus 15 over 11 minus 1 over 2. Okay, top by top, bottom by bottom. What do we have? X is equal to top by top. 45 over 11 minus 1. Well, that's 11 elevenths, and it's all over 2. So how many elevenths do we have? We have 34 elevenths over 2. So we're having 34 elevenths. Well, half of 34 elevenths is just 17 elevenths where I come from. So that is 17 elevenths. Whee. Okay. That was nasty, wasn't it? You know, typically they don't ask you to do one where there's a fraction involved, but they could, and they have. So you got to be alive to it as well and be good for it. All of those questions, gents, I really think you should just go over them, restart them, have another shot at it, see can you get the right answer out. Okay, thanks a million, and hopefully you found this revision good, and we'll continue on with it this week. I'll try and pick out important parts of the course. We did a lot today, by the way. That was simultaneous equations of 3 variables, so simultaneous equations, 1 linear, 1 non-linear, a little bit of complex numbers thrown in there as well, and solving cubic. Okay, that's a lot. Okay, so you know you could take a day or two, I think, to get over that property. And of course, have a look at past papers as well. You know, they're a great source, and the marking scheme, I should say, is online, so you can see whether you have it right or not. Okay, gents, take care. All the best.